Homework 4 here builds on homework 3. If you remember in homework 3 we looked at the definitions for atoms, elements, mixtures and compounds. And here in homework 4 we've got lots of different diagrams of different substances, some of which are atoms, elements, mixtures and compounds, and you of course have to identify them. It's maybe not quite as simple as that, but we'll go through it. I'm not going to tell you each and every one of them. You're going to have to figure some of them out for yourself, but I'll certainly help you with some. First off then, we've got this picture here. It's the picture on the front page of the workbook because it's possibly one of the most important pictures that you will see. Okay, it is a picture of the smallest particle that makes up everything, whether it be a solid, a liquid or a gas. Hopefully that's a hint. And you can see it's made of different subatomic particles. And I've even left these blank so you can name these subatomic particles. So maybe you can do that for me. Right, diagram number 2. It's clearly made up of two different things. Okay, so the question is it a compound or is it a mixture? That's what it's going to come down to. Now in a compound, the particles are chemically joined to one another. In a mixture, they're just mixed. Okay, now in a compound, there will be a neat and tidy arrangement, whereas in a mixture, it will just be a mess. Okay, so I think this is a regular arrangement, a neat and tidy arrangement. So maybe you can label that one for me. Here we've got 2 oxygen atoms. Okay, 2 oxygen atoms. I can't see any other atoms there. I can see 2 oxygen atoms. So that's a pure substance. That's the type of substance made up of just one type of atom. Whereas here we've got a carbon and an oxygen. Okay, now there was one definition we didn't do last time, okay, and that was molecule. Now molecule is a substance that's made up of 2 or more non-metals joined together. So I'll give you a little hint here. Both these two are molecules, but they are different apart from that. So these are both molecules, but they're also different, because this is made up of just one type of atom and this is made up of 2 types of atom. They're both molecules because oxygen is a non-metal and carbon and oxygen are both non-metals. So these are molecules as well. I'll explain more about that in the lesson if you're not sure, because a molecule does confuse some people. A molecule cannot contain a metal. Okay, here we've got 2 different types of substance. Okay, and they're not regularly arranged. Okay. Now this diagram could be a couple of different things. I'm going to tell you, okay, this is a solid, okay, because some of you might think it's a liquid, and you know that would be entirely reasonable. I'm just going to tell you it's a solid. Okay, now if it's a solid, then what we have here, this is a perfect diagram for a mixture of metals or an alloy. Okay, so we've got 2 different types of atom. Okay, and they're not chemically joined. This would be a good picture for, say, an alloy. Okay, so you can label that one up. Here, we've got 2 of the same atoms. Okay, and we've got 2 of a different type of atom here. Okay, now these are not chemically joined. This is a gas because there's space between the particles. So this could be a good example of the air, where one is nitrogen, the other is oxygen. I mean, it's not perfect for the air, but it's just something to help you think. Because in the air there's 80% nitrogen, 20% oxygen. It's far more nitrogen and oxygen, whereas this is fairly 50-50, isn't it? But there's 2 different gases, not chemically joined. So is that an atom, an element, a compound, or a mixture? That's my question. Here, again, we've got this one on its own. Okay, this is an atom. We've got green atoms, and again a gas. Joins this time a molecule again. This is a molecule. Okay, we've got a diatomic molecule here. These purple ones. So again, is this an atom, an element, a compound, or a mixture? Well, let's help you out a little bit. I suppose all 3 of these are probably fairly clear mixtures. But here's the question: what are they a mixture of? This is a mixture of atoms and molecules. Can you tell me what each of these 3 are mixtures of? Okay, next question on this homework. Write a balanced symbol equation for the potassium reacting with oxygen. Okay, so you need to put the symbol for potassium and the symbols for oxygen and the symbol for potassium oxide. Now I've given you the formula of potassium oxide, so there's going to be an arrow there. and we're going to have potassium oxide on this side. So I need potassium here and oxygen there, and then we need it balanced. Remember, oxygen is one of those diatomic molecules that we've looked at in the last couple of homeworks. Okay, that's the group. They are the molecule. They are the elements on the periodic table that always exist as pairs. So here's the periodic table. These diatomic molecules in equations are always nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. So that they would be H2, N2, O2, F2, Cl2, Br2, I2. Okay, so we'd have to write the oxygen with that little 2 after it. Potassium, that's a metal. Metals always hang around on their own. So find potassium in the periodic table. I'll give you a clue on that one. Potassium is down here in group 1. So find me the symbol. Okay. Next question on homework 4. So these next couple of questions are about calcium carbonates reacting with hydrochloric acid, and you writing a balanced equation for that with state symbols, and then the 2 things that you observe or see when you carry out that reaction. Okay, so to do that, what we'll do is I'll do a little reaction here, which is a bit different. Okay, I've got here is a glass of water and some electrolyte sports drink tablets. Now these electrolyte sports drink tablets, okay, they contain sodium bicarbonate and some citric acid. So those are going to react together in there. Okay, so my question is, what do you see when the reaction starts? Okay, so what are we seeing? So I'm interested in the 2 observations of this reaction, and then we'll think about putting a chemical equation together for this reaction. Okay, now hopefully you can see the reaction going on in there. And what we'll do is we'll just leave that going now, and I'll put the reaction equation together, and then we'll come back and have a look at it at the end, and hopefully you can compare the before and the after. So what we're not doing here is answering this question. You're doing that. I'm answering a different equation. Okay, that's the sodium bicarbonate that was in those electrolyte sports drink tablets. That's the formula for sodium bicarbonate. Okay, now there's a citric acid in those tablets, that's what it's reacting with, but I'm just going to imagine it's reacting with hydrochloric acid just because it keeps the equation a bit simpler. Now the tablet to start with was a solid, so a state symbol is S. Okay, it's reacting with hydrochloric acid. Now hydrochloric acid is an aqueous solution. Okay, and then that reacts to make sodium chloride and water and carbon dioxide. Okay, state symbols. The sodium chloride, the salt will be dissolved, and that's what we're after with the sports drink tablets. We're after replacing the salts that are sweated out during exercise because it stops getting cramps and things like that. Water is a pure substance, so it is a liquid, and carbon dioxide is a gas. So what do we see in this reaction? The clue is in the state symbols. We start with a solid tablet and we start with a solution. And at the end, we have gas, a solution, and a liquid. So 2 observations. Well, let's go back to having a quick look at that drink. Now the reaction's finished because it's finished now. Okay, and let's have a good look at that. Now, can we see the tablets we started with? Okay, I think that's dissolved, hasn't it? There's no solid left in there anymore. There's no solid left in there. So we don't see that at all. And look at the state symbols. Start with a solid, no solid on this side. And this is the one everybody would forget. The solid dissolves. And the state symbols tell us that. The other observation, I guess you got that straight away, didn't you? You saw it bubbling. You saw it fizzing. So they would be our 2 observations. So that hopefully will be helpful in answering this question about calcium carbonate. Well, that's our reactant. In my example, we started with sodium hydrogen carbonate. Okay, reacting with hydrochloric acid, I've given you a formula for that one down there. And I've given you formulae for products as well. So hopefully you can fill those in now. That equation will need balancing. I do want state symbols as well. Final question, how many atoms in aluminium nitrate? So I'm not going to do this one for you. I'll think of another one. Let's use iron sulfate as an example. Iron 3 sulfate. This would be the formula of iron 3 sulfate. Okay, well there would have 2 ions, so that would be 2 ions, 2 Fe. Sulfur, S, there's a 1 after it, you can't see the 1, okay? If there's no number, there's always a 1. So S1, there's 1 sulfur, but outside the brackets is a 3, so 1 times 3 is 3, so there's 3 sulfurs. 3 sulfurs. Oxygen 4 inside the brackets, but outside the brackets it's 3, so 4 times 3 is 12. 12 oxygen. So that's 15, 17. So in that iron sulfate there was 17 atoms. Okay, have a think about aluminium nitrate now.